Good afternoon and good morning to some. I'm Vivian from Singapore Water Association. Thank you for attending today's webinar on Israeli digital water technologies, jointly organized with the Economic and Trade Mission Embassies of Israel, Singapore, supported by PUB, Singapore's National Water Agency, and the Israel Export Institute. There will be separate meeting links for the P2P networking provided in the chat towards the end of the session. Please join the respective meetings to further your discussion. Before we proceed, I'd like to touch on some housekeeping rules and disclaimer clauses. To ensure better connectivity, your microphone and camera will be turned off. You may communicate with us after the event. Please share your questions in the Q&A icon, where speakers will try to provide answers where possible during the webinar or in separate follow-up emails. Do identify yourself so we can respond to any unanswered questions. We will be recording this session and reserve the rights to the video. Please complete a post-event survey which, upon return, will forward the recording and presentation deck to the respondents. All information shared is for general information only and does not contain or convey any legal advice or administrative assistance. Information shared today is true and accurate as of publication date. The organizers and speakers reserve all rights in the provided materials. For today's session, we are honored to have Mr. Yoav Seder, Head of Economy and Trade Mission to Singapore at Ministry of Economy and Industry, Israel, to give us the welcome address. Mr. Seder, please.
Thanks so much, Vivian. Hi, everyone. Thank you for joining. We're very happy to do this event today. So like Vivian mentioned, my name is Yoav. I head the Israel Economic and Trade Mission to Singapore. And our office here is basically connecting Israel and Singapore ecosystems and trying to connect as many, mainly private sector entities, companies from one country to the other. Of course, technology is our main focus. And as part of my team, I have Jurani Solano, which heads the water sector in our office. And I'm sure some of you at least, or most of you even in the audience know Jurani. So this is what we do, and we're very happy to do this event with the great partners SWA. And I'll take the opportunity to thank Vivian for all the work over the years, Vivian, not just this event, and also for Lily for all the work so far. And we're very privileged, to have you guys as partners. I also want to thank Ron from the Export Institute, from the water sector, for his work on this event. Actually, today is an interesting day in Israel. Yesterday we had elections, and now everybody's keeping track very anxiously to see what are the final results. I think it's still not final, like something like 90% of the votes have counted, and now we'll have to wait a day or two, I think, for the final results. But I'm sure all the Israelis in the panelists or in the audience are aware of that. I think, you know, I've been 3 years here in Singapore, and there are so many collaborations on the tech sides that are already going on. And I think the water sector is definitely one of the more interesting ones, and the one we see the most amount of collaborations. And I think it's due to a number of reasons. I think it has to do to a lot of similarities between New Zealand and Singapore. I think both of us are small countries, you know. Singapore is 5.5 million, Israel is 9 million people. We're both rich. Singapore is a bit richer though. We're both technologically advanced. And when it comes to water, both of us have like, water is a very scarce resource naturally, let's say. And I think there's these commonalities, and of course all the history of collaborating also between the countries is the reason that so much is going on. But I think there's a lot of untapped potential as well. And we hope this event can help fulfill some of this untapped potential. I want to encourage everyone in the audience to stay for the networking sessions. These times of virtual events, we've done quite a few. I'm sure SW have also. And we want to really encourage the people in the audience and the panelists to talk to one another. So if you can, after the event, take time, go into the links and try to have some conversations. I think it's really worthwhile, even if it's just a short, a couple of minutes just to get to know one another. I think it would be really worthwhile for everyone. And again, if we compare it to physical events we used to do in the past, where you have to go physically to an event, to set a meeting, to start a conversation, you can't really get out of fast if it's not interesting. Now it's very easy. You just give a few minutes, try to see if there's any potential, and if not, you just move on. So really encourage the people in the audience to attend that. And thank you once again, Vivian.
Thank you, Yoav. May we now invite Mr. Mo Ting Liang, Deputy Director of Industry and Technology Collaboration Department, PUB, Singapore's National Water Agency, to give us an introduction to the Singapore's water ecosystem. Mr. Mo, please.
Hey, hi, good afternoon, everyone. Hi, Mr. Yoav Seidel and Mr. Itai Sadi. I hope everyone is well, and very glad that the Water Association and the Israeli Embassy has come together to organize this event. So as Mr. Yoav said just now, Singapore and Israel have many commonalities. We are both water scarce countries. Singapore is water scarce because we are so small, we are not able to collect every single drop of rainfall. And Israel is water scarce because you are mostly a desert nation. But I think we have both made various efforts to overcome our constraints, and we have managed to thrive economically despite our water situation. So today, for my presentation, I'm just going to cover a bit of the Singapore water ecosystem, as well as touch on some of the digital plans that we have in line with the theme of the webinar today. Next. So as Vivian mentioned, next please. As Vivian mentioned, I come from PUB, which is Singapore's National Water Agency. We manage the entire water loop in Singapore in an integrated manner. And this means that we manage water supply, wastewater, drainage as one. And because we use recycled water, every drop of wastewater that is generated in Singapore is actually collected and treated and then reused. And this is what we mean by a closed loop. And 16 years ago, in 2005, we started to use desalination. So now we have a diversified portfolio of water resources. So in short, our mission as the National Water Agency is to supply good water, reclaim used water, as well as tame stormwater. Next slide, please. So as a small country, we face many challenges. Water is just one of the many challenges that we have. We are so small that 2 Singapores can actually fit into Metro Tel Aviv. And this smallness, as I mentioned just now, is the root cause of our water scarcity. And then we have rising water demand because our population is growing and the industry is also growing. We expect our water demand to double between now and 2060. And our land size is not going to double correspondingly. So we have to find new ways to find new water. Lastly, we face rising public expectations of service of uninterrupted clean water 24 hours a day, 7 days a week. People also expect to have uninterrupted sanitation services. And this is why we have to step up our game to meet the expectations of the population. Next slide. We would not have been able to add water recycling and desalination to our portfolio of water resources, if not for the fact that we leaned a lot on technology. And technology is the key to enable us to overcome our water challenges and meet our long-term water sustainability. With technology, we are able to increase our water resources, improve our water quality, but at the same time, drive down our energy footprint, our chemical usage, our manpower needs, and our waste generated. Next slide. So the use of technology encompasses many things. Okay, we spend quite a fair bit of national funds on research and development. But at the same time, technology also encompasses digitalization. But why digitalize, you may ask? By leveraging advancements in digital and information communication technology, PUB is able to future-proof our water supply so that we can achieve adequacy, resiliency, and sustainability. We aspire to use data, connectivity, and computing decisively in our operations to transform the way that we serve our customers. At the same time, we are always aiming to improve productivity and efficiency. Next slide. So we've just started on our digitalization journey. In fact, we have developed a smart PUB roadmap, which is a 5-year plan to deploy 5 identified technology enablers across the entire water value chain. And these 5 enablers are shown on the slide. You have IoT, we have data analytics, we have the use of digital twins, we have AI, and then the use of robotics and unmanned systems to perform manual tasks. These technology enablers were chosen because there are many promising applications that have large potential in enhancing our processes, such as gathering operational data, enhancing our situational awareness, supporting our inspection and surveillance requirements, as well as facilitating data-driven decision-making. Next slide. So the 5 technology enablers are deployed across all aspects of operations, and as you see on the top row of arrows. And these areas of operation range from drainage to water supply to water distribution, and eventually to the water reclamation. For example, the use of smart technology enables predictive flood management and optimized operations in our water treatment plants. Sensors are also deployed widely to enable preemptive leak detection and monitoring of illegal discharge into the sewer. And this is important, as I said, because we recycle our wastewater. We want to make sure that whatever is thrown in the sewers is within the parameters of what we can treat. And we firmly believe that by embarking on this smart transformation, we can deliver our mission and achieve operational excellence. Next slide. So in the water treatment plants, the smart technologies help to improve our operational efficiency and enhance safety and security. Sensors and robots enable more extensive data capture, while enhanced analytics using machine learning and AI enables prescriptive and predictive decision support. Next slide. In addition, I missed one point that I did make just now. In addition, unmanned aerial vehicles and robotic platforms also enable PUB officers to perform inspection, surveillance, and data collection in areas that are difficult to access. Next slide. Similarly, in the water distribution and wastewater networks, we deploy smart technologies to improve PUB's capabilities in network operations. Today, we have over 300 sensors installed island-wide to help us monitor our water quality, the pressure, the flow, and this enables us to supply good water to our consumers. In our drainage network, we have 600 flow and water level sensors and CCTVs installed, and there are more to be installed in the near future. And lastly, in our sewers, we similarly track used water quality with level sensors, flow sensors, VOC sensors, as well as what we have recently installed, which are the microbial electrochemical sensors to detect heavy metals. Next slide. We have made some progress, but we need to learn more from the world, and hence we want to collaborate with the industry very closely. We are sure that we are unable to develop everything by ourselves, and the global water industry is an important part of our network to help us get new technologies to deliver our mission. Today in Singapore, we have over 200 water companies across all parts of the water value chain. We may not have many Israeli companies in our midst, but certainly we hope that this will change. And actually, we are testing a few Israeli technologies in PUB at this moment. We have tried rapid E. coli detection kits. We have implemented flow reversal technology from Israel, and this enables us to increase our recovery rate for our water recycling from 75 to 90%. And I believe we have also implemented the Aquarius acoustic leak detection sensors. And this enables us to have some visual chart of the noise generated from the water leakages. Next slide. So supporting all these foreign companies in Singapore is the Singapore Water Exchange, which is a purpose-built facility that houses many different water companies. It's a vibrant ecosystem that leverages mutual strengths of the different companies so that they can collaborate and push the frontiers of water innovation together. Currently, the Water Exchange has about 30 water companies here, ranging from the startups all the way to the MNCs. And we also have a range of different activities to showcase our water technologies and connect overseas companies with the Singapore water industry. And it is my wish that one day I will have more Israeli companies here in the Water Exchange with their own offices or their co-working desks, and we hope to collaborate with these companies in time to come. Last slide, please. So allow me to do some pitching for the Singapore International Water Week, which is due to be held in June this year as a hybrid event for the Leaders Summit, as well as a virtual online event for the Water Convention, as well as the Water Expo. The dates are as shown. The hybrid Water Leaders Summit is held on the 21st of June, whereas the Water Convention, as well as the Water Exhibition, will be held over 2 weeks from the 21st of June to the 2nd of July. And the key thematic areas are as shown, where we have climate resilience, digital water, as well as resource circularity. So we look forward to welcome our Israeli friends to join us at the Water Week in 2 months' time. And we look forward to more exchanges with you soon. Thank you very much.
Thank you, Mr. Mo. May we now invite Mr. Itai Sagi, Head of Urban Water and Sewage Department, Israeli Water Authority, to share with us on the implementation of digital technologies in the Israeli municipal water system. Mr. Sagi, please.
Hi, good morning. Can I share my slides, please? Can you hear me, please?
Yes, we can hear you.
Oh, can you let me? Oh, thank you. Okay, so good morning and thank you for having me. Let me the opportunity to present you some of the Israel water sector and of course implementation of digital technologies. My name is Itai Sagi and I'm head of urban water and sewage department within the Israel Water Authority. Basically, I represent the regulator with all engineering aspects. So most of you know that Israel is located right in the heart of the Middle East, which is a scarcity water area. Hence, our water shortage make us we have to make sure that we have enough water in our for all our customers. So you can see that the water consumption in Israel divided by sectors. You can see that most of it is for the agriculture use. And because we have a short resource of water, we have to make sure that we reuse most of our water and making sure that we have cope with the demand along the years. We have to make sure that the balance between the water demand and the water resource is balanced. You can see for the next years we'll have a quite shortage, And that's why we are making sure that we have a lot of desalination plants as a resource for water. The principles and goals of our organization as the Water Authority is first of all to make sure that the suppliers can have a reliable water and wastewater service for the consumers, and making sure that as it is a valuable commodity, we have to make sure that everyone can get the same services no matter where they live, in the far north or in the far south of the country, for all uses: agriculture, potable water, or industry. Around 2010, there was a big reform in the water sector. The government decided that this sector is much important, that it cannot be held, and cannot be held and implement with the municipalities, and the water corporation or utilities were established. And during these years, we made sure that the investment in the water sector are much higher than they used to be when the municipalities were holding this sector. You can see it, just a short example of a few municipalities and the difference in the infrastructure investments. And of course, you can see it also in the non-revenue water improvement. Much work was done in this area, and you can see it that in the general non-revenue water improvement, you can see it that today we stand around 9.5% of all our water demand, which is quite a remarkable achievement. Of course, my department responsibility is the engineering aspect for the urban area, which means all engineering aspects of the water corporation work. And that means that we have to make sure that they have uniform service levels for all consumers, and standardized regulation for engineering activities. That means that around 2017, we established these regulations, making sure that all water corporations stand with these standards. Some of these are regards for water and sewage master plans renewal schedule, to cope with the development in the country, mapping all the infrastructure and making it smart grids, as my colleague from the Singapore organization just mentioned, using GIS technologies, and of course, computerizing management and monitoring water and wastewater infrastructure. That means that we have to make sure that we have the same water supply pressure in all the system, measuring and preventing water losses, and of course, ensuring minimum of burst and spillage to the nature of sewage. And to cope with these standards, we have to make sure that we use smart digitalized technologies. Some of them you will meet in a few minutes. They will represent themselves, and it means that we use leak detection, sewage quality monitoring and treatment, and of course water metering. And another section that we're very proud of is alternative water supply and emergency situations. For instance, the earthquake situation or war situation, unfortunately, still can happen in our region. Some footage of these technologies, you can see the leak detection. It will be represented later on. You have you implement some sensors along the grid, and can have monitored and managed by the field experts. Of course, we have also the technology to sewage leak detection using satellite footage. You basically map the area you need to check. Afterwards, you have to make sure that the data received from the satellite is then compromised in the area using GRP or CCTV systems. Some sewage level detections. This is an old implementation. It's been renovated and it's much more sophisticated nowadays. And just to make sure that the Israel Water Authority along the years make sure that these technologies can be implemented in the water utilities by funding part of the projects. By that, we can help those startup companies in their beta version, making sure that they have a pilot area or a pilot infrastructure to implement their technology, and making sure that the pilot is performed well using the utility and the startup, and making sure that later on they can evaluate. Thank you very much. If you want to send me some questions via mail or the forum, it's fine. Thank you.
Thank you, Mr. Sagi. Now we'll get to hear the digital water technologies from our 5 Israeli companies. We have sharing by Mr. Oded Fruchman from Aquarius Spectrum, Mr. Guy Marie from IOSite, Mr. Ren Kadem from Ready Technologies, Professor Ofer Daham from Sensoy, and Mr. Peter Paz from CuraPipe. Gentlemen, over to you, please.
So hello, everybody. My name is Oded Fruchman, and I'm the Chief Business Development Officer for Aquarius Spectrum. Honored to be here representing Aquarius. In Aquarius, we developed acoustic technology to help water utilities reduce their non-revenue water, prevent water pipe burst, and do pipe condition assessment. We already deployed thousands of sensors around the world, soon to be adopted in Singapore as well. And I'll share some of that knowledge with you. In a nutshell, we install our sensors along the pipeline. We need about 4 sensors per kilometer. And each night when it's very quiet, we take 20 seconds, we record 20 seconds of the vibrations on the pipe and send this information to the cloud where everything is analyzed. If we hear the same level of noise coming from the same location, then we produce an alert on the map for the water utility that looks like this. On the left side, we categorize the leaks by A, B, C. A, it's a big size leak. C, it's a small leak. And on the right-hand side, we provide an exact position of the leak on the map. This is Suez, New Jersey, just across the Hudson from Manhattan. If I zoom into a specific leak, you would be able to see that this leak is 144 feet from sensor number 1. That means 50 meters, we provide very, very accurate location of the leak, and we estimate the size of the leak. We can tell the frequencies of the sound of the leak and so forth. We just introduced a new version a couple of weeks ago that is able to trace 2 leaks, even 3 between 2 sensors. It's really, really cutting edge technology, a very innovative feature, so that if there is a pump in the system that is masking the leaks, we are able to hear the pump and a leak. So very strong feature. In terms of technology, we don't have any limitations. We support all pipe materials and all diameters. We have vibration sensors that can monitor iron and asbestos cement pipe. These are simply strapped on to the fire hydrant. 5 minutes installation. We have below ground sensors that listen to the pipe with a stethoscope. And we have hydrophones for monitoring large pipes and PVC and polyethylene pipes. They all transmit the signal in 3G, 4G. We're coming up with 5G soon in the next few months. And there is a 5 years battery within every sensor. What we do is called detection by multispectral correlation. We actually correlate between every two sensors every night, and if there is a sound of a leak, even a very, very small one, we'll pick it up and identify the exact location, which will come up as a spike on our screen and tell us the location of that leak. There are other technologies in the market, but what makes us different is the fact that we record a sound, this 20-second sound every day, and you can actually download and listen to it. We provide accurate location. We need less sensors than everybody else. And we have false low positive rate because we take our time before we make a decision that this is a leak, 3 to 15 correlations until we make a decision, and that way we ramp up the accuracy of the system. If you keep our sensors long enough, we can provide pipe condition assessment report based on the history of repair, the background leaks which are found with our solution, and how fast those leaks are evolving. We can monitor each leak and see how fast it is growing. It doesn't happen often, but when it does, it means that the condition of the pipe is very, very poor. At the end of the day, we are coloring the problematic section of the customer, and that way the customer knows which pipes to replace. And as you may know, replacing 1 kilometer of pipe costs about $1 million. So you want to make sure before you replace a pipe that you are replacing the right pipe. And we provide a list to the water utility of which is the problematic section and materials that they should focus and replace them, so that they can focus not just on the old pipes. If they don't have any data, they replace the old pipe first, but actually replace the problematic pipes instead. Like in this example here, you can see a pipe that was just laid a few years ago in 2017 that is causing a lot of problems to a water utility that has very old pipes going back to 1900. That's the power of big data analytics. On a large scale project like the one we did with Suez, New Jersey, where we deployed 2,000 sensors, monitoring 3 areas within New Jersey. In the first 2 years, we found 120 leaks, and we managed to reduce the non-revenue water in those 3 locations somewhere between 15% to 62%. So quite amazing results after two years. We also developed a mobile technology that it's a mobile sensor that when you plug it into any Android phone, transforms the phone into a leak detection device that allows you to listen, survey, and correlate. You don't have to be a leak detection specialist. You press the green button, it gives you a number. The higher the number, the closer you are to the leak. And between 2 mobile phones, you can correlate, and it will give you the exact position of the leak. Thames Water is using it on a daily basis in London, doing thousands of samples each day. And I can tell you that in the last 6 months, we managed to find almost 3,000 leaks with the mobile technology alone. We have an analyst team that is reviewing the results on a daily basis, and once a week we'll call each customer, tell them which leaks they should go and send their crew out to investigate. So we're not just selling the technology, we're actually hand-holding each customer on a weekly basis. We are globally, this is our global footprint. I'm happy to say, I'm honored actually to say that PUBS chose us to monitor their large diameter pipes. We're going to implement 900 hydrophones soon on the trunk main pipes of Singapore. We already deployed more than 3,000 sensors in the US with Suez and American Water. We work with the top water utilities in the UK and Italy. And so is in Israel, of course, Jerusalem, Tel Aviv, the Israeli army, and others. Yeah, so this is our footprint within the US, as I said, working with the large water utilities, private ones and public ones as well. Best way forward is always to conduct a pilot. This is something that we always demonstrate, and also PUBS checked us against all the competition in the market with a very, very hard pilot that checks our abilities. to generate leaks and find them within less than 3 meters away from the actual location. Demonstrating such ability doesn't take more than a week, in which we will get your GIS, analyze it, and suggest where to install the sensors and which kind of sensors to use, and then conduct a trial for a week before you make a decision about a large-scale capital investment. So this can be demonstrated rather quickly. Just to summarize my presentation, we provide accurate location, very large distance between the sensors, low false positive rate, pipe condition assessment reports, a user interface that in 30 minutes you'll be able to operate it, very good support, integration between the mobile technology and the fixed solution. And we also do pressure monitoring and catch pressure transient with our multi-sensor. Thank you very much. Please join me on the next session, on the private section. Thank you.
Thank you, Mr. Puchman. Now, may we have Mr. Guy Mary from IO site?
So, hello, can you hear me?
Yes.
Good. Let me just share my presentation. Could you see the presentation?
Yes, we do.
Okay, thank you very much. And it's a pleasure to be here. And it's been very interesting until now. And I hope you'll find my presentation interesting as well. Actually, I joined this session right after another meeting with PUB. So we're kind of like already involved with some discussions with PUB, also with a local partner in Singapore. So I'll talk a little bit about that. What we do is data management and analytics for smart water systems, and we have a group of engineers, a software development team, and data scientists, algorithm experts. We have over 100 installations worldwide. And our objective currently is to continue international growth. We started in Israel, basically captured market leadership in Israel, expanded gradually to the US and China. And now we're kind of like opening up our markets. And as I mentioned, Singapore is a primary target market for us. And we've been in touch with PUB thanks to actually it started with the Israel Economic Mission introduction. We have a local partner in Singapore, Flowtech Controls. And we're really, really happy to kind of like continue exploring opportunities in the market. And we're about data. We're about utilizing data to improve performance and resilience across the water sector. So data can help water quality, monitoring, improve accessibility, operational efficiency, reliability of equipment, of machinery, affordability, and obviously protect the environment. Data has the potential to serve all these objectives across the water sector. And in many cases, you see facilities that are really, really complex, data-rich facilities, like, for example, large water reclamation or wastewater treatment plants, like the Shafdan you see here, the largest one in Israel, or the Sorek desalination plant, which is one of the largest in Israel, one of the largest in the world. And they have tens of thousands of data points. And what can you do with those data points? By the way, 2 of those are using our system. They're a client of ours. The challenges for utilities are that there's a lot of systems, there's no synchronization between the data. There's a lot of data, but there's a lot of systems, no synchronization, and the data is not organized. And that's exactly where we come in. We're taking the data from the various systems and we manage it and we serve it in the variety of outputs like alerts, reports, analytics, and other types of outputs on multiple devices like web, mobile, and others. So that's where we come in. It's especially critical we've just recognized it over the last year or so, that when water professionals are away from the facilities, it's critical to be able to maintain business continuity in a comprehensive way, in a convenient way, in a collaborative way, and in a secure way from a cybersecurity perspective. While you're remotely, and our system provides out of those. And what you can see here are 2 examples. One is the home of one of the operation managers of one of the desalination plants in Israel using our system, and that's a real screenshot from a mobile phone of the watershed protection solution we have in Israel. That's the new normal. You have to be able to do all these things remotely. We provide an integrated, what we call smart water suite. It's the iGreen data management platform with several advanced analytics solutions, which are I'm going to talk about in a minute. Those are the ones on the right-hand side. In terms of clients, we have clients across the water sector. We've been operating since 2008, so we have a lot of clients. And in Israel, Mekorot, the National Water Company; in the US, the City of Chicago Water Department; American Water; in China, BWG. We work with both facilities like water treatment, wastewater treatment plants, like this one is the Jardine Water Purification Plant in Chicago, or the Shafdan wastewater treatment plant that I mentioned. Desalination is a big segment of ours. All the desalination plants in Israel use our system, as well as the Israeli Water Authority to supervise those desalination plants. And also we have a couple of installations in Cyprus and also Carlsbad in the United States and other. We also do watershed protection, and we have a real-time water quality monitoring, 2 projects, one in Israel, the Jordan River, one in the US, the Chicago River. And we're working in the Mekorot and the water cluster current in Chicago, and we have some other parts of the system. So we can see we cover the entire water cycle, much like what PUB, I mean, kind of like PUB is an ideal client for us because they cover the entire water system. So we work with all the various entities there. And the way we approach our customers and our solutions is through the implementation of what I call the 4 pillars of data-driven water management: the data foundation, the insightful outputs, the analytics, and the prevention and response. The data foundation is all about the ability to collect the data, cleanse, virtualize the data. The outputs, dashboards, reports, and so forth. The analytics is more like the AI type, the sophistication, the mind behind everything. And the prevention and response is the actions you act on, what you see or what you learn. And I'm going to talk a little bit about that. All of them are embedded in our solution suite. The data foundation, you can see here the various data sources we've been collecting data from: historians, SCADA system, control systems, AMR, lab, GIS, online sensors, offline data, multiple collection protocols. There's nothing in the water world we haven't been able to take into our system. And then there's the modeling in a nice structure tree. And there's the cleansing and normalization, which is very important because sometimes you have noise. You need to know how to clean that noise to make the data real. So this is like the data foundation. Before you start doing anything, focus on the data foundation. Now the outputs are, straightforward, like dashboards, map views, reports, sophisticated reports. All these things are the first layer of what we do. The more sophisticated stuff that we do, the analytics, we have several solutions. One is iShed, is for real-time water quality monitoring in rivers and watersheds. As I mentioned, it's about detecting anomalies in water quality in real time and calculating downstream propagation. We've been able to eliminate 95% of false alerts in the Jordan River in Israel. As I mentioned, we have a project in Chicago and just about to begin another project, a big project in the US. iDetect is an early fault detection engine. It's about machine failure, quality exceptions, flow and pressure anomalies. We have 2 projects in desalination plants in Israel, predicting pump breakdown based on vibration data and temperature data. So these are the anomaly detection and early fault prediction. The optimization, we also have a couple of optimization solutions. One is for water treatment and wastewater treatment plants. So these basically take historical data of the operations and demand data and demand predictions and help the facilities optimize their operations, basically saving energy and chemicals and reducing significantly operational costs. And we have another solution for the water supply system for multi-objective water supply system optimization. It's called iOptimate. We have also a non-revenue water and leak detection solution, iNet, which is working on the DMA level, not the...
You have 2 more minutes.
Thank you. Not the specific the specifics like Aquarius, more on the DMA level. We have an event management module I mentioned. This is the operational layer. You need to know how to act when you do find that something is going on. There's a rules engine. You know that a certain threshold has been exceeded. you want, then alerts are being sent automatically to whoever is responsible. They know they need to act on it, not just know it, but actually act on it. So we have an event management module, which is being supported by this rule engine. And we also have prevention, like a maintenance management module, which is basically a task management module, both for web and mobile task management usage. So this is kind of like covering the entire, those four pillars of data-driven water management, as I mentioned. The data foundation makes sure everything is organized, cleans, all the data is there, everything is collected, then provide the outputs that are needed, analytics like the iShed, the iDetect and others, and the prevention and response, the acting on that. And that's basically the content of our presentation. And I think we also like to begin with a pilot. We're a very focused pilot. There's a lot of options. And now we're actually exploring with POV some potential pilots. But we would really be happy to work with any of you and try and identify a pilot to begin with. And I would be happy if you reach out to me. If you can join the session afterwards, it would be great. Otherwise, you have my email, my mobile phone number. Thank you very much.
Thank you, Mr. Mary. Next, we have Mr. Ran Kadam from Rally Technologies. Mr. Kadam, please. Mr. Kadam, are you able to share your screen?
Can you see my screen, please?
Yes, we can, but it's not full screen. Yes, now it is.
Now full screen. Okay, sorry for the delay. I have some small problem, but now everything is okay. My name is Ran Kadam from Rally Technologies, and today I represent with you Realitech holistic solution for digital transformation in water utilities. Actually, it also considers new generation of SCADA system, but as we see, it's much more than just a SCADA. And the idea is to make the digital transformation smart, but at the same time, simple and affordable. I'll start with a few words about Rally Technologies. We were established more than 10 years ago as a pioneer in IoT and cloud computing solutions, developing Realitech real-time remote control and data management solution. Today, we are already a proven technology used in more than 40 different countries, more than 1,000 installations only in Israel, as you can see on the left side, and also thousands of installations all over the world, mainly in water and sanitation, but you also can find us in other applications like electricity, gas, building, industrial, and others. And the bottom of the slide, you can see some of the global users of our technology. A little bit about what is Realitech holistic solution for real-time remote control. The idea is having holistic hardware and software solution, as you can see on the right side on the drawing, for real-time remote control of data management system from the infrastructure level, from the ICT and the SCADA level, up to the cybersecurity and the data analytics level, actually giving a single source solution to the entire demands for smart water network. What is the difference between our solution and traditional solution? Traditional solution, even those that are already dealing with IoT, is usually built of a lot of different kinds of solution and technologies that have a limited infrastructure between them. Sometimes you will have sensors or controllers from different kinds of users which are not interfacing with each other, and you have to have separate software in order to try to collect the data, share it, to analyze it. And actually our solution is combining the entire technologies from the server until the data analytics in one simple solution that makes it very simple and easy to install and to use, and make it also very cost effective. Our system is actually made only of 3 components. On the left side, you can see the data producer. This is the only thing that you actually have to install in our system. As you can see on the photo here, you actually install it in the control cabin, the electricity cabin, and then you can connect all the devices on site. It can be PLCs, sensors, analyzers, whatsoever, different kind of protocols, different kind of physical communication port. All of them can be connected in parallel to our unit. From there, it goes to our second component, which is the Central Online Management Portal, our cloud portal, which is the brain, the soul, and the heart of the system in manage everything, the historian data, the real-time data, the security, the alert, the control, the user interface. Actually, this does most of the, almost everything. And the third part is the user interface, which is browser-based. So actually, you don't have to install any software or user interface. Just anyone that authorized get a username and password, and he can enter the specific URL of the project. The system is seamless interfacing with existing equipment and SCADA and software and so on. So you don't have to replace things, and you can use whatever you want. It supports most of the industrial communication protocol. The installation is very fast and simple. Last month, our distributor in Israel connected 9 different sites in one day by one technician to our system. It's simple to use, and actually no maintenance, because you don't have to control to maintain server or software or different kind of communication technology. The only the hardware, the ISACs that install on site, and you can forget from it. The idea of the system is really to become a holistic solution for the entire network. Never mind if you want to combine a device, water meter, sensors, or the entire sites, or all the sites. Everything can be connected to one system for one network. No limits of data, no limits of user, no limits of kinds of the devices, no limit size of location, and there are no limits of distance between sites or type of topography. And we'll see in a minute that we have a project that is separate on many different countries. The system includes also built-in editor to allow customized BI, operational, dashboard, trends, tables, and so on. And you can see here BI, trends, different kind of dashboards. As you can see, it can be in different kind of languages, here in Chinese, in English, and in Hebrew. As you're using a local browser, each one can build directly his dashboard in the local language, which makes it, again, very friendly to use. One another capabilities of system is geo-presentation for real-time asset health. With our system, you can see all the sites which are connected to our system in a real time, and what is their situation. If there is some problem, some alert, you will see it immediately. If there's communication problem, you see it as well. And of course, if everything is right, by just clicking on it, you can drill in and to know what is the problem. So in one shot, you can get a real-time asset health of the entire system, from the smallest size to the largest one. Not only that, it also can act as a network hub, interfacing with other solutions in the network. We are, by the way, already cooperate with IOSite that you heard before us, and here it's actually Aquarius Spectrum. You can see again, it's a geo presentation of the system, but here you have also something called 15 event. Here actually we are connected to Aquarius Spectrum that in one click, the high-level managers can see the bottom lines of the activity of the leak detection made by Aquarius. We get a real-time data of the active leaks. We calculated getting the average leaks of each one of the categories. You remember ABC of Aquarius. We get the cost of the water from the utility, and then immediately we can calculate the real-time loss of the day, month, whatever. We can get to see how it is in compare a parameter that was decided. It can be the average, the plan, or whatsoever. And we can see the trend, how it is compared to the last month, year, week, whatsoever. So in one shot, we can get, or the high-level management can know what is going on in the system, also in different kind of other software that are using in the system. The system is built on a hierarchy organization structure. It means that you can get different level on the corporate, can get access to different level of sites, from the individual one to the local sites, to the utility, to the regional, and it can be national or even international. And that, of course, improve the corporate governance of the high-level management or corporate when they have a lot of remote sites all over. Here you can see, by the way, in this project, it's not only sites in one country, it's different kind of countries, and still all of them are seen in one project. And as you can see, you can know the real-time asset health of each one of the assets. Of course, two important things in our solution is very smart alert management that can be used different kind, emails, SMS, Telegram, voice, and so on. And of course, the security, which is a very basic and very important part of our solution. We are authorized to use by the Israeli Water Authority, as you can see here. And actually, we are used in most of the water utilities in Israel today. And we put a lot of attention and effort to our system. And it actually can be used even in very strategic application like energy and gas and so on. Case studies, again, this is here just some examples. This is water quality in Vietnam, I think. This is a lift station in Israel, different kind of application all over. This is the United States and so on. This is in Israel. I just want to share with you one project that we just done lately in Mexico State. They had a huge challenge of limited corporate governance. Only basic data analytics was done, pure maintenance and service level with high OPEX, and a lot of losses causes for large damage in cost and different remote sites. They install our solution, first of all, in 3 sites as a pilot. And the results were, by the way, the installation was done in 2 or 3 days for the 3 sites. There was an increase in operational safety, service without interruption, significant saving in water and in electricity. And actually, they immediately expand the project for 20 sites, and they plan to do the entire network. It was stopped for a while because of COVID-19, but we hope to continue in the near future. Just to summarize the benefits of our system, again, it's single source, it's affordable and accessible to any utility in any size or type. It's simple, fast, and undistributed installation. It's maintenance-free and easy to use. No need for special IT capabilities, manpower, of infrastructure. It is a 100% modular, from 1 to unlimited, hundreds of sites and even more in project interfacing, seamless interfacing with existing equipment and software. No limits of use of data on sites, making the data available in a real time, improves collaboration, coordination, and data sharing within the organization, and improve corporate governance. And the idea at the end of the day that we are allowing to share the IT and the OT together in a real time, and by that providing significant benefits along the main operative dimension: cost, quality, speed, reliability, and security.
Ron, you are out of time,
thank you very much. It was my pleasure, and I'm sorry that I was a little bit slow. Thank you.
Thank you, Mr. Rankidem. Next, we have Professor Ofer Dahan from Sensoy. Professor, please.
Yes. Can you, just a second, cannot start video. Okay, hello. One more split of a second. Can you hear and see me?
Yes, we do.
Okay, hello. I will start by sharing, of course. Just 1 second. Okay, I'm Ofer Dahan. I'm from the Ben Gurion University of the Negev in Israel and from Sensoil. And I will be talking about a new or novel technology for monitoring the subsurface. While all previous speakers were talking mostly about water system themselves, whether it is the technology of the water system or it is how to manage data and detect the aspects related to the water system. Sensor system is designed to monitor the subsurface, mostly in the geological formation and from engineering point of view and from water quality point of view. And instead of describing in details, I'd like to show you a little movie that describes the concept of monitoring the unsaturated zone, what is the importance of it, and then we can go on to the details. So here I'd like to show you a short video which will describe the meaning of the data that Sensoil can provide. So I'm showing now a little video.
Water is the source of life. Groundwater is the world's most important source of water. It is vital to ensure the groundwater is clean and uncontaminated by pollutants. Groundwater is usually polluted by contaminants originating on the land's surface, transported by water percolating through the unsaturated zone to the water table. Early detection of pollutants in the unsaturated zone is critical to save groundwater and other water resources. Existing monitoring programs based on groundwater sampling methods are ineffective since pollution is only detected once it reaches the aquifer. Therefore, monitoring of the unsaturated zone is critical for protection of water resource quality. Sensoil presents the first ever real-time Vados Zone Monitoring System, VMS. The VMS is composed of flexible sleeves hosting monitoring units, implemented in uncased, slanted boreholes. These enable continuous measurements of variations in the hydraulic and chemical properties of the unsaturated zone. The monitoring units include flexible water content sensors and Vados zone sampling ports. The system measures water flow and contaminant migration from land surface to the water table. Real-time hydraulic data and water samples for chemical analysis are continuously collected and registered by a dedicated control panel. Data from the unsaturated zone is directly accessible via cloud from anywhere. Once installed, Sensoil's monitoring system provides real-time information on pollution potential. This enables effective management and protection of water resources. Sensoil's typical water resource management applications include protection of groundwater from potential pollution, remediation of contaminated sites, water reservoirs, and enhanced safety of earthen dams. Let's protect ground.
So back here. So now that we understand a little bit about the meaning of the unsaturated zone and the importance of it, I'd like to present the technology and how it can be used. In general, it is a set of sensors and sampling port that are designed to be installed on a long sleeve going into the unsaturated zone from land surface, which can provide us information on an area which until recently hasn't been monitored all over the world. And therefore, we got some catastrophes in water qualities because the most important water resource, as was shown in the movie, was related to the groundwater resources. The system has been installed in many places all over the world, and with for variety of organization, from academic institutes through governmental and non-governmental organization, or which are interested in protecting groundwater or remediation of contaminated sites. And here you can see we have a substantial, though we're a small company on a technology which is very, very new. Until recently, actually, this zone has not been monitoring at all. We have installations all over the world, as you can see here, from Australia in the east to the US, and actually in 2 weeks, we'll have another new installation in the USA. And here you can see just a few pictures from installation setups, and I'd like to move on to show what are the relevant applications. So one application, which is the most obvious and important one, is protection of groundwater and water resource, other related water resources from pollution. As shown in the movie, every pollution event starts on the surface, but it has to cross the unsaturated zone before it reaches the groundwater. This means that currently we can identify pollution years after it happens. Our system can show in real-time information about the process of pollution as it is going on. Another application, once it is already be identified, Sensor system can help dramatically in remediation of the contaminated sites and reduce significantly the time required for decontamination of the unsaturated zone anywhere between the topsoil to the groundwater below. It has been used also in landfills. For example, here in landfill, once the system is installed in the landfill, we can monitor the leachate generation and the leachate migration in the heap of waste and under the waste and the unsaturated zone, and to see the immediate impact on the groundwater below. One important application is related to safety of earthen dams. Here you can see an earthen dam with a system installed in it. It provides real-time information on the saturation degree of the sediments. If you are an engineer dam engineer, you know that the stability of the dam is practically dependent on the water flowing within the dam. And our system is the only system currently in the world that can measure water propagation in the unsaturated section of the dam. It is also related or can be used in long levees to prevent the collapse of the levees by knowing exactly what are the conditions within the levees. And of course, also in the agricultural sector. I don't know if you know it, but 85% of the world's water crises which are related to shortage are related to pollution created by the agricultural sector. Our system can also be used for prevention of pollution related to the agricultural sectors by managing well both the water and fertilizer applications. So on and all, in summarizing, Sensoil is the only company currently on the world that provide monitoring services to the unsaturated zone. While everyone is focusing on the groundwater, we focus on what's happening above it to provide information about whatever is happening between the topsoil to the groundwater below. And here I'm coming to the end of my time, I think, and I'll be happy to, if you join us for later on to discuss specific issues related to monitoring options. Here are our phones, and I'll be happy to, if you join us, if you interested in it. And thank you.
Thank you, Professor. Next, last but not least, we have Mr. Paz from CuraPipe. Peter, please.
This is Ben Schenker speaking. I will be going through the presentation for CuraPipe. Could you give me the ability to host and okay. Right, do you hear me?
Yes.
Okay. So I will be delivering the presentation for CuraPipe instead of Peter. Do you see my screen, the main screen?
Yeah.
Or the small screen?
It's the main screen.
Okay, great. Okay, so good day to you all. My name is Ben Schenker, and I'm serving as CEO for CuraPipe System from Israel. Thank you very much for shortlisting CuraPipe and for me to present here today. And we will be speaking about water loss, where CuraPipe delivers a game-changing new platform which can make a huge difference in that matter. So CuraPipe was established in 2007 by a group of PhDs, and now with over a decade of R&D, We are now offering our third project generation, which is fully tested and has gained accreditation for use with potable water in several jurisdictions. The technology has proved massive leakage reduction where it was executed and is implemented successfully in various markets, presenting it is operational and scalable and delivering substantial savings. Today, Thaler is actively implemented and piloted in water companies in various markets, as mentioned. We are handling the certification for each market as per local regulation. We are currently going through the NSF 61 certification process, and we are very conscious about our IP with an extensive portfolio, patent portfolio. So why is the innovation required in this field? Find and fix is becoming more costly as its marginal effect reduces, and especially when dealing with background leakage. On the other hand, water utilities will replace aging infrastructure to a very low degree, 1% to 2%, applying high expenditure and civil inconvenience, but resulting in no real effect on the total water loss. So QRpipe creates a new market category of bulk leakage reduction to cost effectively reduce leakage by presenting Thaler trenchless automated leakage repair, which is first to present a game-changing, low-cost and durable trenchless repair solution. So there are many technologies about detection, but not so much on actual repair, and specifically from within the pipe, which is what we do. So the Thaler technology can address multiple leaks within a pipe section in a single intervention. So we're not limited to one leak. It can seal different types of leaks on different types of pipe materials, on the mains as well as on laterals. It enables a systematic approach to to address leakage and reduce leakage in an area with no detection and with no disruption. So the core technology is based on a proprietary pig train, which is comprised of viscose materials and special curing substance. The pig train is propelled by water. Following launching of the pig train through an insertion point, it is to an isolated pipe section. It is the curing substance is penetrating leaky pinholes, cracks and joints, and would plug the leaks. It is then extracted through an extraction point. What we see now is a demo rig which is built above ground to demonstrate the technology while simulating different types of leaks. As will be seen, different types of leaks will be treated and sealed on the main pipe as well as on laterals. We see that right now in a single intervention. Following the extraction of the pig train through an extraction point, the material would cure. The entire process would take 4 to 6 hours. Subsequently, the curing substance will harden and leaks will be permanently cured. The pig train is not reusable and can be safely disposed of. And as mentioned, the technology is safe for use with potable water in several jurisdictions. So what we see here is a few samples. We see here a pinhole, a 3mm pinhole. The section can be up to 400 meters in length and the treated diameter up to 200 millimeters. This is a case of a flange. What we see here is that the curing substance will eventually cover the entire circumference and okay. So I understand we have a technical problem and nothing is moving.
Yeah, we can't see the movie.
Can't see the movie. Okay. Right. So, okay.
Ben?
Ken.
Please continue.
Right, okay, do you see anything now?
No, maybe in the networking session you might be
okay.
Inviting the audience to see the video.
Right, okay, but do you see the presentation or you don't even see the presentation now?
We don't see the presentation. I think you need to stop your video.
Right.
Go back to your presentation, please.
Right, okay. Do you see the presentation now?
It's loading.
Okay. Do you see the screen? Do you see any presentation now, or nothing is?
Nothing is showing.
Nothing is showing. You just hear me.
Yeah.
Okay. So I'll probably have to move to another place to. So you just hear me basically.
And see
okay.
you.
And
but
see
not
me.
the presentation.
But not the presentation, right? Okay.
Maybe
so,
try to stop sharing and try sharing again.
Yeah, I did that. Do you see the presentation now?
No, unfortunately not.
Okay. So basically, that's so the technology basically enables the cure.
The presentation is up.
Sorry?
We can see your slides now.
You see the slide now? Okay.
Yeah.
Right. Okay. So this is a lateral, which can be treated as part of treating an entire section. For longevity, we've gone through a testing through a UK laboratory to test the cure to hold for at least 10 years. This was done in the UK, and here are some case studies this is from Italy. So basically, this was done in northern Italy with water utility A2A that have quite an aging infrastructure. And basically, they always take us to the most difficult places. And this case was a section going downhill of about over 1 kilometer, with very challenging, with massive leakage. As can be seen, there were 3 leaks or 4 leaks in this particular section, with the largest one about 5,000 liters and total aggregate leakage of 9,000 liters. And this was completely sealed after 3 cycles. There was another section of 300 meters with lower leakage that was treated as well, and also a third one. And altogether, there were 3 sections totaling 1 kilometer, and savings of 19 million liters per year were saved in 3 working days. And this case study basically presents the ability to successfully seal high leaks and not just background leakage. We've been advised by the customer just 2 weeks ago that they looked into the continuously monitoring the cure, and very happy with the results. So the seal is holding tight. This is yet another case from South Africa. Basically, what we see here is a small neighborhood with pipe network which is made of PVC. Very difficult to detect leakage on PVC with usual acoustic measures. So our licensee there decided to take the entire region, which was about 2,000 meters, and treat this with cure pipe. And basically, there was a substantial reduction to 0 of leakage with savings of 75,000 cubic meters annually, with a very short ROI in this case. And what we are presenting here is the ability to take bulk leakage reduction, which is basically applying effectively in an area and reduce leakage without detection and without excavation. Our business model is that we license the use of the technology to capable and well-positioned business partners in the territory. We sell a license package, which will include also training, delivery of the operational equipment, and the package of material, initial package of materials. And obviously, the licensee will acquire materials on an ongoing basis to repair leaks, and of course, we will supply ongoing support. Again, the key takeaway is it cures all types of leaks on different types of pipe materials up to a length of 400 meters. We can treat also the mains, also the laterals and the mains, and it extends the asset's life because the cure has a long life, and obviously no need to locate and excavate for the leaks, and it is certified for use with drinking water. And I thank you very much for your time, and we'll be ready to answer any questions, and obviously we'll be happy to see you in our room later.
Thank you, Ben. Thank you, speakers, for your excellent presentations.
Sorry?
Yes, for further queries on the event, please contact the SWA Executive Office. As mentioned earlier, please join the respective meetings links provided in the chat to further your discussion and networking. Thank you all for coming to join us today, and thank you, speakers, for your excellent presentations. Please have a nice day.